All right, this video is going to talk a little bit about what we call binomial probabilities, and I'm going to start off describing sort of why we need binomial probabilities. So let's consider this idea here on the page. You spin this spinner 3 times. The spinner at the right, there's a triangle, a circle, a square, and a pentagon there. You could land on any one of those 4 things. You win each time you spin a square. Right? Find the probability for each number of successes. Right? So again, on the right there, we've got this probability notation saying, well, the probability of 3 successes is saying I'm going to land on a square 3 times in a row, right? Probability of 2 successes, so I could land on a square 2 of the 3 times, so it's something, either a triangle or a circle or a pentagon one of those other times. Again, 1 success or 0 successes. Now, again, I don't care about the other 3. So really, this is what we call a binomial probability, right? Binomial meaning 2 possibilities. And by that, we mean there's either success or failure. I'm not worried about the actual outcome of the spinner as much as did I get success or fail. So all the possible outcomes are that we could have 3 successes, 2 successes, right? And then a failure, a success, fail, success, or fail and then 2 successes, right? And again, same thing, success with 2 failures, success in between the failures, success after the failures, or all 3 failures, right? The trick here is we have to consider, again, those probabilities. The probability of 3 successes is saying, well, hey, I'm going to have 0.25% chance, or 0.25 chance, right, probability, 25% chance of any one success, right? So we would often say the probability of success is 0.25. The probability of failure, which we'll just call Q, is 0.75, right? The other 3 possibilities. Well, 3 successes then is 0.25 on each one of those, right? We're going to have success and another success and another success. So essentially, probability of 3 successes is just taking 0.25 to the 3rd power, which is 0.015625. Now you can round that kind of wherever you'd like to. Again, that's the probability of 3 successes going on. The one trick, though, is the probability of 2 successes actually has 3 scenarios here, right? We've got to consider all 3 of these, right, scenarios as 2 successes. So now we have to say, well, it's success, success, and failure. But again, that assumes the order in which we've multiplied. We could have also had the failure between them or the failure at the beginning. So all 3 of these scenarios, right, go together to form that R equals 2, or 2 successful, right, spins. So I need to take 0.25, again, squared, times 0.75, but also multiplied by, right, the fact that there are 3 possible scenarios that can happen in. So 0.14, right, 0.625 on there. Same idea when we talk about 1 success, 2 failures. We could have had that success at the beginning, the middle, or the end. So all 3 of those, right, would be single successes. There's only one of the 3 of them that are successes, but all 3 of these need to be put together to form that idea. So again, we would say 0.25 times 0.75 twice, but then times 3, right? There's 3 scenarios there. So again, 0.25 times 0.75, sorry, I'm typing on my calculator here real quick, times 3, and we get 0.421875. And then finally, the much easier one, again, there's only one way to get 0 successes, right? Note I'm saying R, though, that's the number of successes. So number of successes, right, is that R value. But again, that just assumes 0.75 to the 3rd, or 0.421875. And one thing you'll notice if you add all of these up, again, 0.42 plus 0.42 is a little more than 0.84. Add on another 14 is 0.96, right? A little higher than that. And again, a little bigger than that. And again, add on up here. They all add up. If we add them all together, right? If we put those all together, they should add up to exactly 1, everything that could happen. Now that idea here of how we get this formula is, again, what's called the binomial probability formula. We need to take the number of successful trials, right, R, out of n trials by multiplying the probability of success by the probability of failure for each of those trials, but also by the number of, right, this NCR in front, the number of ways in which that can happen. The number of ways that can happen. So again, a spinner is spun 5 times. What's the probability we win win 2 out of those 5 times? If the orange is a quarter of the circle, well, again, we're going to spin 5 times. That's the number of spins. We're going to win twice. The probability of success was 1/4, and the probability of failure, therefore, is 3/4, right? 1 minus P, right, equals Q. And if we want to win, right, probability of winning 2 times, right? Well, this is an independent. Yes, it is, because again, you're either success or failure, but no spin affects the next spin. So what we can say is, right, we want 5 spins with 2 successful. We're going to take the number of, or the probability of success then is going to happen twice, and the probability of failure is going to happen 3 times, right? Or essentially 5 minus 2. Notice that n minus r up here in our formula, right? Again, because we want 2 successes, 3 failures. But again, that 5 choose 2, right? Very simply, 5 choose 2 is telling us that there are 10 possible scenarios in which this happens, right? 2 successes, 3 failures, 3 failures, 2 successes, the mix of all those possibilities. And so we want to take, again, 1/16 times 10 times 27 over 16, or over, sorry, 64, right? 4 to the 3rd power there. Oops. Getting my numbers mixed up in here. So again, 1/16 times 27/64 times 10, right? And we'll end up finding out that our probability is 0.2637 rounded off, right? Approximately that much. But there's our plan. There's our idea, right? Again, it's the number of successes combined with the number of failures there. NCR times successful probability to the R, number of successes, times the failure, right, probability, Q, to the number of failures, n minus r. Okay. I hope that helps you with binomial probabilities. Feel free to tune in for more videos if you want to just see more examples. Otherwise, have a great day.